Okay, so everybody go ahead and close your eyes. Focus. Go ahead and close your eyes. And on the whenever I say go, you guys start to count, okay? All right, ready? I'll just tell you when to stop. Okay, go.
1, 2, 3, 4.
Okay, stop. Yay! What number did you start at?
1,
What number did you start at?
1.
Okay, these are our hide and seek numbers from now on, okay? That was it. These are our hide and seek numbers. What number did you start at? One more time. 1. All right. So go ahead on your paper. That was it. That was it. Go ahead and write a natural, natural. A natural number is from, tell me one more time. What number did y'all start at? 1 to infinity. It's used for counting positions. A natural number from 1 to infinity. Infinity and beyond. 1. All right. So I need everybody to say whole numbers.
Whole numbers.
Emphasize whole numbers.
Whole numbers.
What letter or what number did your lips make when you said whole numbers? A circle. So what number is that? 0. All right. Everybody say whole numbers.
Whole numbers.
So whole numbers is, so this is a whole number. The next one, a whole number starts at, what number did y'all say our lips made when we say whole numbers? 0. This is the importance here. 0 to infinity.
Hmm.
So we have our hide and seek numbers, like our 1. Y'all pay attention, listen. We have our hide and seek numbers, 1, 2, 3, 4, 5. And then we have our whole numbers. So on game days and anything else, most of the time you're just going to see whole numbers because whole numbers also include all of your hide and seek numbers. So for the most part, we won't really see natural numbers on paper. We'll mainly see whole numbers, but we need to know that natural numbers start at what number?
1.
And whole numbers start at 0. So for our example, just put EX for example, put 0, comma 1, comma 2, comma 3, dot, 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 all the way into infinity. This one is going to be integers. My goodness. T-E-G-E-R.
There you go.
And an integer number is a whole number. Write it down. It's a whole number. And its opposite. It's a whole number and its opposite. Got it? Not a fraction or a decimal. I repeat, not in all uppercase. Not a fraction or a decimal. Next, these are called rational numbers. And if y'all paid attention since the beginning of school, whenever I write the objective and I had the word rational numbers, I put some lips because that's a key vocabulary. That's the language of the discipline. That's our math. So a rational, R-A-T-I-O-N-A-L. R-A-T-I-O-N-A-L. That can be written as a decimal, including repeating. Do y'all know what a repeating decimal looks like? It looks like 0.33 with a line over it. That's the same as 1/3. You want to see why? You ask why?
Yes.
Good question. Let me show you. So if I have 1/3, and what we're going to learn is how to change a fraction to a decimal, and we do that by doing division. Okay? So we divide. We put the top and bottom out, right? Numerator in, denominator out. Can I do 3 times a number to get 1 or almost 1? No. So I would have to add a decimal and a 0. And what do we know what we do with our decimal? Bring it straight up. Now I can do 3. How many groups of 3 can I fit into 10? Or how many times can 3 go into 10? 3. Okay, so 3 times 3 is what number? 9. Everybody paying attention? You don't have to write it. You can, but you don't have to, but you can. 10 take away 9. 1. And then I have a remainder, and my goal is to get the decimal, so I have to add another 0 and bring it down. Oh, what do you know? I'm back at 10. But I know that 3 times what equals is going to get me closer to 10. So that's going to be another 3. 3 times 3 equals 9. 10 minus 9? 1. Add a 0 because I have a remainder. Oh, what do you know? I'm back at 10. What do you think is going to happen? Say it again. Say it louder again. Over and over and over. That's what we call a repeating decimal. And when we get to that point, we can just, whatever number is repeating, we just put the line over it. This is 1/3 as a decimal, and I'm sorry, as a fraction, and the decimal equivalent is 0.333. That's what's on the board as well, because that's one we want you to remember. Memorize that 1/3 is the same as 0.33333 repeating. Very good question. So a repeating decimal looks like that. Okay, so a rational number that can be written as a decimal, including repeating, a fraction, F-R-A-C-T-I-O-N, a ratio, and a percent, P-E-R-C-E-N-T. Anybody know how to write the percent sign? Yeah, so they look like that. That's the percent sign. Percent sign. So a fraction, decimal, percent, including repeated decimals. Exactly. A fraction goes here. Fraction. F-R-A-C-T-I-O-N. And percent. Percent. Cient. Cient. No siéntate. Cient. What does cient mean?
100.
100. What does per mean?
Each.
Each. So percent is always going to be out of 100. Percent. We'll learn about that. That's why when we ask you, we need you to know how to multiply times 100. How many times do we move the decimal to multiply times 100? 2 times. So guess what? Just to show you, I didn't do this in the last class, but if the decimal is 0.33 and I want to know the percent is 33%, which is the same as 1/3, which is the same as 0.33 as a decimal, and as a percent is 33%. This is why we need you to know when you multiply times 100, it's moving the decimal 2 spaces over. All right. So let me erase this. This one right here, this one is going to be, we did rational. Cross this out. All right, now let's talk. Let's talk. All right, so we have some long jump cards here. And so what we're going to do is we're going to look at a situation, a scenario. And the first one says sandpit card. It says the long jump sandpit card is labeled with the unit of measurement of feet to help the summer camp trainers determine how far an athlete jumped. Has anybody ever seen a track meet before? You've been to a track meet? Have you been to a football stadium that has a track around it? Yeah. Yes. Okay. So at these football stadiums, they have sometimes track meets where people run. And then they have something called a long jump. Has anybody seen a long jump? Has anybody ever tried to stand somewhere and jump as far as you can jump? Anybody want to try right now? Look at your notes from just a few minutes ago, the yellow paper of notes. And let's figure out, to jump 2 feet. We saw him jump 2 feet. Not 1/2, not 1/3, 2 feet. So you and your shoulder partner, you guys talk together and figure out how would we classify that number? So you need to open your notes. So discuss with your partner because I'm going to use the randomizer. The number is 2. What are you thinking? What are y'all thinking?
Nice,
huh?
kid. Good observation.
Okay, why?
Good observation. I think it's going to be on this side, right?
Yes. Yes, you are correct. You are correct. Good. It's a whole number, but is it also a natural number?
What do y'all think?
Yes, you are correct. All right, good. Good, good, good.
Is there any decimals?
What do
in
y'all
it?
thinking? Yes,
Is
sir.
there any
The
decimals
sandpit
in the
card.
number?
What are y'all thinking?
No. Is there any fractions in the number? No. So you can already eliminate which one.
Yes. Do you agree? Yeah? Whole number? Okay, cool. All right, so what do you guys think? Everybody, what do y'all think? Whole number. Good.
Nice.
Can somebody tell me why it is not an integer? Why is it not an integer? Mr. Pullen said our integers are on the number line left and right. Can you tell me why it's not an integer?
It doesn't have a decimal or like a negative.
It doesn't have a negative. Everybody tell your partner it doesn't have a negative.
It doesn't have a negative.
No. All right, good. All right,
Sandpit,
next
whole
one.
number.
This is the takeoff board card. It says a long jumper must run down a runway and jump from a line represented by a wooden board onto a sandpit. This wooden board can be up to 42 inches long, and it's called the takeoff board. So this board right here would be here, right? So I will have to, on your mark, and say go, run, 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 jump from here, okay? That board, they're saying that board is 42 inches long. So we're on the second one on the bottom. And it says, how would you classify the numbers on the takeoff card? So the numbers here are 0 and 42. 0 and 42. How would you classify these numbers? 0 and 42. What kind of numbers would they be?
Think about it. You can discuss with your partner. You should hear some math discussions.
Say it again. What number is natural?
Natural is 1, 2, 3.
So our numbers are 0 and 42. It keeps going, yeah? It's so 40. I agree with you that 42 would be here, but is 0 a natural number?
Kid.
No,
It's a whole. But isn't
I mean, by
42
they, yeah. I like
also
it.
a whole number?
Well, no,
Yes,
just
it
put
is.
the classification. If you think it's whole
can
number,
keep going, yeah.
natural number,
Mhm.
just write
It's
it in.
yes, good. Whole number.
I think so. Make sure you are writing under takeoff board.
What you got?
Okay, right here.
Yes,
Under takeoff board.
yay. Good job.
Yeah, appreciate it, bro.
So with these questions, you guys, y'all have another opportunity to get questions correct on big game days without doing any math. You have another opportunity to get questions correct on big game days without doing any math. Have we done any math here? Have we added, subtracted, multiplied, divided? No, but you will have questions where you have to just identify where do these numbers actually go.
Mhm.
All right, so go ahead. What type of numbers are these? 0 and 42? Whole numbers. 42 is also a
Kid,
natural
before you
number. That's a
stand back
counting number. However, 0 is
Don't be
not a
mad at
natural
nobody.
number.
Let's be
So
mad
they
at you.
both belong in the whole number
Right.
group.
This
So
in here.
whole numbers. Whole numbers. All right, next one. This is runway card. It says a long jumper must run down a runway and jump from a line represented by a wooden board on a sandpit. One long jumper move back 3 meters from the sandpit and move back again to get on the runway, which is 4 meters from the sandpit. So the two numbers we're trying to identify are -4 and -3. So look at your notes. Talk to your partner. We have -4 and -3. -4 and
Nice, kid.
-3. We need to identify where do these numbers go. Anybody want to share? What are you thinking? Integer. Why?
It's integer because if it's the opposite number, or something,
Yes.
which in this case is a negative,
Yes.
so that means
Yes.
it will be a negative. And since it's a negative, it says it right here, it's an integer.
Awesome. Awesome. I like also how you said if it's the opposite. This right here means opposite. Can everybody write this down on your runway card box? POSITE. Put -4. That negative means opposite. This negative means opposite. I need you to know that. I need you to know that a subtraction sign means opposite. OPPOSITE. Perfect. Yes, and then those. And then draw an arrow to the negative symbol. This is also the same as the subtraction sign. That means opposite. This is the opposite of what number? The opposite of what number? 4. What's the opposite of positive 4? Negative 4. And that's negative 4. Okay. Next card. Long jump landing card. Here are numbers. It's the same thing, you guys. It's another situation, but we have 2 different numbers. 4.5 and 6.5. Where are these going to go? 4.5 and 6.5.
Good job.
Tell me, everybody.
Rational.
Rational numbers.
Rational.
Somebody
That's a
tell me
rational
why.
number.
Because it's a decimal.
Good
Awesome.
job.
Rational. Because of the decimal. Our fractions, our decimals, and percents are rational numbers. Except some situations, which we'll explain later.